Let's get into the second step of the PCB layout workflow, which includes setting the outline based on the various geometrical constraints for our project. So at the moment, we've got the bundle of components all laid together at some part of the layout sheet. So what I want to do next is to draw a rough outline of the board based on simple geometrical constraints, at least for this example. In other circuits, obviously, and other PCBs, constraints can be far more complicated, but here we'll just keep it simple. So to define the geometrical constraints, I ask questions similar to these. For example, how large would I like my LED torch to be? And this dictates the board's overall size and cost. How will I turn the LED on and off, which indicates where the approximate location of the button or the switch might be. For example, I might want to be able to turn the LED on and off momentarily with a push button using my thumb, so that will dictate its position relative to the rest of the torch. Then what's the biggest component of the board? In this case, I've got a large, comparatively at least, large footprint for the battery. You can see how much larger this is compared to everything else. So this essentially dictates how wide, at least, the outline for this PCB will be. And then also the question of how will I attach the board to an enclosure. For example, I want to have the option of designing a simple 3D printed enclosure, and then I have to figure out how to mount securely the PCB inside that enclosure. It could perhaps be done with clips or with a mounting hole. I can use a screw to secure it against the enclosure. That's another consideration. So these questions will help me determine the physical dimensions and the shape of the board. Just a short interruption to let you know that this video is part of my comprehensive KiCad course that will teach you every aspect of creating printed circuit boards with KiCad from scratch. Go to the course page to learn more about it if you want. Find the link to the course page in the description below and treat yourself with a discount coupon for my YouTube viewers. Okay, let's continue with the video. So for this particular design, I do have some answers, of course. So after some consideration and drawing some rough outlines on a piece of paper, I decided that I will go for a outline that is about 65 millimeters in length and 25 millimeters in height, or width, I should say. Then I'm going to use a momentary button so that I can press that button with my thumb. And when I press it, the LED goes on. It doesn't need to remain on. So I'm not going to use a slide switch that can be placed in a different position. Obviously, the biggest component, as I said, is the battery cell. So I'm going to put that towards the back. So imagine that I'm holding the torch in my hand. The battery cell will be towards the inside of the torch, where the outside is where the LED will be. So that also dictates the position of the LED on that PCB. And for the 3D printed enclosure, I decided to attach the LED torch board to the enclosure utilizing a screw, mounting bosses, or sliding rails, or perhaps a combination of those. So the board itself should include one screw mounting hole. So with all these constraints in place, I decided to continue. Let's switch to the layers tab, and I've already got the edge cuts layer selected. So I'm going to use a rectangle tool. I'm going to say go around to the drawing around here. So just keep an eye down here where the status indicators indicate the dx, dy, and the distance. And remember that I want to draw a rough outline of around 66 millimeters long and 26 millimeters in height. To be more precise, I'll go for 66.25 millimeters in one dimension and 26.50 millimeters in the other direction. Before I do that, actually, I should have a look at the settings because I want to look at what the grid overrides are for the PCB editor. And you can see for the graphics, I'm just going to enable graphics. I have selected a size of 0.127 millimeters. So I'm going to use grid overrides for this, regardless of what the manually selected grid is. So click OK, ensure that the grid overrides is selected and enabled. And I've got the edge cuts selected. So let's draw this rectangle. Now I'm going to press the space bar before I start drawing, and you can see that the dx and dy and distance values are 0. Do that again. They're 0. So now I'm going to click and start drawing. You can see this is drawing an actual rectangle. So I can't draw a shape, a rectangular shape, where the two dimensions, height and length, are different because they're locked to being together. So I'm just going to click to finish drawing and then use these handles with the simple arrow tool. Just select again. I need to select graphics. The filter is working. So select graphics, zoom in, select the rectangle, and then use the handles to get the dimension as I wanted. So again, there's going to be 0 in one corner, and then let's go for 66.25 or approximate. This is, remember, rough, so we don't need to be super accurate. So let's say 66.16 in one dimension is good. And for the other dimension, I'm going to go for 26.50. Yeah, about that is good. All right. So this is good as it is. So now I want to make sure that my components fit. So I'm going to select the footprints. Start with the battery cell because it is the biggest one. So I can place that over here. The switch will go just in front of it because this is where approximately my thumb will be able to press the button. The LED will go right at the front. And the current limiting resistor somewhere else. I'm just going to rotate that here as well, like this. And that leaves room for a screw hole right there. And of course, you can see there's a lot of empty space, but we're going to deal with that later. Okay. Going to move that because you can see there is space. Just change the dimensions of the container box, just to make sure that I don't have too much wasted space. All right, that looks good. Now for the mounting hole, I'm going to use a circular tool. I'm still working in the edge cuts layer. So I'm going to zoom in. I'm even going to use the grid, and I'll place a hole right here. I'm going to place a hole right here like this. Okay. Just centering the components slightly. So that looks okay. I can have a look at the 3D representation, and it looks like that now. So that's good progress. I can continue to reduce the size that the torch PCB will occupy, because remember that smaller size is also smaller cost. So I can bring a few items together, a bit closer together. Just move that around here and that around here. And I can also, since everything is on the same axis, I can align all of these using the align tools, align to vertical center like that. So now everything is centered around a horizontal line right there, which aesthetically is obviously very good. And finally, I'm going to move the left edge of this box closer to D1. Okay, I'll save the progress we've made so far and have a look at the 3D representation of our board so far, and it looks pretty good. Okay, so at this point, according to the PCB layout workflow, the next step would be to place the footprints on the board. But we've already done that really here in the outline and constraints step 2. So essentially I combined these two steps together because it is a fairly simple circuit with not that many components. So before I finish the lecture, which essentially will be a combined lecture for steps 2 and 3, just want to have another quick look to make sure that this is how I want things to go. I have already designed the outline as a rough outline in this case. I'm going to improve it in a later lecture after I do the wiring. I've got a mounting hole. I can go for more than one mounting hole. So for example, I can have a couple, but I think that one is enough because the PCB will be able to stay in place by matching closely the width of the container in which it will be placed, and with the help of the screw it won't be movable. So one screw is enough. And then finally the LED and its position I think is good as it is, and yeah, I can just remove some length as well just to make the board slightly smaller. So I'm happy with this. I'm going to continue then with routing, which is the fourth step of the workflow, where I'll design routes, copper routes to connect the pads together.